Welcome back to class. This is the fourth module. This module focuses on assessment of vulnerability and penetration testing. Learning objectives. At the end of this lesson, you should be able to have a comprehensive knowledge of vulnerability scanning, and then look at the exploitation techniques, whether they are manual techniques or automated techniques, perform impact assessment, and finally categorize risks. So let's begin with vulnerability scanning. The lines of code here are meant for emulation of automated scanning. So for scanning, we have automated and we have manual. Manual is when you do manual inspection of the source code. But automated scanning is performed when you use some tools to perform the scanning. So the primary tool that we use for scanning at your level, we need to know is the Nmap. So the line of code here, Nmap -SV -P, then the port numbers 804435 5000 8080, and then the secure backup is the command that we use to perform scanning on the web application, which is a secure backup, where you're not able to get the secure backup running, as it were. You're expected, like I did before, you're expected to replace the secure backup with the IP address, stable IP address for that. So when Nmap scan is performed, you have expected findings or results are shown in the table here. You're going to see the ports. You're going to see the state of the port. In the state of the port, the port might be open, might be closed, might be filtered, might be unfiltered. And then the service is the type of service that's running on that port, and then the version of the service that's running. So we're going to see how that works. The scripts which are prepared as the command, we're going to just pick them, take them to the command prompt or the terminal and see the results, how it works. Then looking at manual testing methodology. So we have 4 major processes. One is code review, which is where you have to perform manual code inspection or review of the source code, which is app.py. And then you have to do that manual inspection for obvious vulnerabilities. And then the second point is black box testing, where you're able to perform the testing without having prior knowledge of the source code. So in the first phase, which is the code review, you're expected to have some knowledge of coding and Python to help you to understand coding errors or vulnerabilities. Then the third one is gray box testing. This time around, you are expected to have a partial knowledge of the code, or the source code, or the code review process. And then the last phase is targeted testing, which focuses on identifying vulnerable endpoints in your source code. The OWASP strategy or techniques or mapping has some layers we have to go through. So the first, we're going to look at the first top 10 as amended in 2021. So the first one is A01 2021, which deals with broken access control, where there is no authentication or where bypass is possible. That first one, the first OWASP top 10 strategy deals with that. And also we have missing authorization checks. And then the second one deals with cryptographic failures. For instance, we have hard-coded secrets in your code where there is no enforcement of HTTPS. When enforcement is done, when your website is visited, or your web application is visited, and it is HTTP, it's supposed to do a redirect to HTTPS. That's where enforcement happens. And also weak password storage. If the password is stored as plain text in the database, it also comes under the second technique or the second layer. Then the third one deals with injection. The injection could be SQL injection, it could be command injection, or it could be cross-site scripting injection, in which is very high. Furthermore, we have security misconfiguration, which is the fourth layer. And that happens where you have a debug mode set to enable in production environment. Ideally, for safe coding process, your debug mode is supposed to be disabled in production environment. Where you have default or weak credentials or you have excessive privileges that are granted. So that all of those come under the fifth one. And the fifth one is where you have variable components like updated Flask version. And one of the things we need to know about Python is that Python depends so much on the states of the packages or the applications that might be dependent on what we call dependencies. So you're expected to work with updated versions of whatever Python package or applications you are dealing with or programs. Or you have potential vulnerable dependencies. They also come under the fifth one. Vulnerabilities, classification. There are several classifications, majorly classify them into five depending on the CVSS. So if the CVSS is between 9 and 10.0, it is critical. For instance, if your application suffers from SQL injection, where authentication bypass and data filtration are possible, or where command injection is possible, or your remote code execution is possible, then the score is between 9 to 10, and that's critical. If it is between 7 and 8.9, then it is high. For instance, if your web application allows client-side good execution, for instance, you have cross-site scripting execution, or your debug mode is enabled, which is possible where your information disclosure can be done. That is high. And then the third one is if the CVSS is between 4 to 6.9, it is medium. For instance, we have hard-coded secrets that allows session hijacking to be done, or there is no input validation that allows multiple injection vectors to be performed. So that comes between 4 and 6.9. And then if the CVSS is between 0.1 to 3.9, then it is low. For instance, you have verbose error messages, which allows information leakage, or you have missing security headers, which allows minor security hardening issues to be exploited. So now looking at exploitation techniques, one, which is seen from labs 1 to 3, one of such exploitation techniques that can be performed on web application is the one we call SQL injection, SQLI. So let's take a deep dive in. There are several variants of SQL injection. One of such is union-based SQL injection. Let me get my pen. Yeah, so this is the first, this first payload is for union. Union select null, command add version, and then null. Then we also have a second variant of that. This allows us, the first one allows us to extract the version of the database. The second one allows attacker to extract the names of the table on the database. And then if the attacker intends to exploit or extract the names of the columns from the user table, then the third payload goes. The fourth one is to extract all user credentials. So that can be done. Let me delete this. Get this out. Now looking at error-based SQL injection, this happens, this is where an error is triggered whenever SQL injection is attempted, or where it is successful, an error is triggered. So you see the payloads written here. We'll see how this works in real life. And then blind injection is actually based on the time. So we call it time-based blind injection, SQL injection, or detection. So usually the payload will carry the time it allows an application to respond. For instance, this code allows 5 seconds. And then we have command injection variants. We have several variants of them. We have basic command injection. We have chained command injection. We have subshell execution, and we have background processes. These are all variants of command injection. And then we also have CATs. This for allows input redirection. We have output redirection. We have pipeline injection, then we have logical operators. Then for cross-site scripting exploitation, there are several methods. The first one allows also, let me get my pen. Okay, so this first one allows for stealing cookies, okay? And then the second payload here allows for hijacking session, and then the third payload allows for implementing keylogger on the application. Let me get this out again. Then we have form hijacking, where an attacker intends to hijack the input form. So this is a payload for that. Then the third thing we need to look at is post-exploitation. What happens when an attacker has gained access into the system? What can be done? So one of such things that can happen is data extraction, or you call it data exfiltration or data stealing. So whatever way you call it, the goal is able to steal data. If the intention of the attacker is to take data, sensitive data from the database or from whatever thing, so that can be done. So for that to happen, we have payload here. The first payload here allows for allows for extracting contents from SQL execution. This is the payload. This one allows for manual execution via unit injection, and then this one allows for stealing sensitive files from the database. Depending on what the intention of the attacker is, then all of this can be, any of this can be implemented. Then the second thing an attacker may want to do, having gained access to the system, is privilege escalation. So privilege escalation is that condition, that process where the attacker tries to have higher rights to perform more functions. Okay, so for instance, the attacker may intend to check for sudo privileges by running the command sudo, and then that is performed. This command does that, checks for sudo privileges, or might want to check for SWID binaries. That's the payload. Okay, now from what we did, I think that was in lab 3 where we had to run the forensic and CS. Once this is executed, you've already implemented a check for SWID binaries. The attacker might intend to check for writable files, that's the first 20 lines of, and then or check for cron jobs using either cat or the list command. As a matter of fact, it's important to run the cat and then run the list command. And then the attacker may attempt to escape container by running these other commands, depending on what the intention is. Let me get this out, then we'll move on. Then the third thing that the attacker might want to do in the post-execution phase is the lateral movements, where he's able to move to any left, move up, move down, move to the right, move to the left, and then just move as a root user, as an administrator. One of such lateral movements attempts is to access MySQL from the application container. So within the container, you might want to access the container. That is the first payload. The second payload is to attempt to access the Elasticsearch. Okay, the third one is to attempt to access the Kibana, and then the last one is what we call password spray. So within the container, you want to see what password can go or can be used. Then we have persistence mechanisms, where the attacker might intend to either create backdoors so they can enter the system at any time and then get whatever he or she wants. So we have creating backdoor with a payload there. We have creating reverse share persistence, will be one of those things that can be done after an attacker has gained access to the system, or create scheduled tasks for persistence, or modify the application source code for backdoor entry. So at any point in time, the attacker can gain access to the system. Now, the other thing we need to look at is risk assessments. So The CVSS scoring depends on the severity of the attack found. Okay, so for SQL injection, which is number one SQL injection, the CVE is given as 2024-0001, and the base score is 9.8. In that case, it is critical. The vector is given, the impact is given. The impact of SQL injection is given authentication bypass, data extraction, or remote code execution. And then for command injection, the base score is 9.0, which is also critical. The vector is given, and the impact is that remote code execution is possible, and the system compromise can also be done. Then cluster scripting, which is given the base score of 7.1, which is high, the vector is given. The impact is that session hijacking is possible, and then credential theft can also be done. And then for debug mode, if it is enabled, the base score is given as 3.5, which is medium. And the impact is that the system could suffer from information disclosure or attack can be facilitated. Then business impact analysis. So when an attacker has gained access to the system, what are the possible things a business can suffer from? What are the things that business can say, can experience? One of such is financial impacts. Let me get the pen. Sorry. So one of it is financial impacts. There could be potential financial loss through fraudulent transfers. There could be regulatory fines that can be imposed by the authority. Of course, the incident response cost might also be high or medium. And then the second impact that can happen is reputational impacts. Of course, there could be reputational damage. There could be customer trust lost in the process. The brand damage, the brand might be damaged, and then competitors might take advantage of the flaws or what is heard in the news or whatever. And then the third one is operational impact, where system downtime can be seen during the remediation period, development resource diversion, and then increased security monitoring costs can also be one of the things that may be seen if an attack is successful against web application. This is the likelihood versus impact matrix. There we are comparing impact against likelihood. So if the impact is low, and then the likelihood is low, then the variance score is that it's going to be low. Let me get pen again and see what happens. So if this is low and this is low, the result is low. All right. So let's say if the impact is high and then the likelihood is medium, then you're going to likely have a high result. So that's what this impact is saying. If the impact is low and the likelihood is high, then you're going to have a high result. So that's what the impact is showing to us, where we compare likelihood against impact. Let me delete this and then move to the next slide. So this further explains the likelihood versus impact matrix we talked about. L for low, high for high, H for high rather, M for medium, and C for critical. So the findings will be that for SQL injection, which is actually given a critical score, it means that the likelihood is going to be high and then the impact is going to be high. And then for the Bogma, which is given medium, it means the likelihood is high and the impact is low. So it's further explaining what I just talked about. This is priority categorization. This classification is important for incident response to know what actions to take depending on what is suffered or what system is exploited or what severity score is seen or is perceived. For instance, if the severity of the risk is high, the fix has to be done within 24 hours. For instance, you have cases of SQL injection or you have login endpoint being exploited, or you have command injection or account endpoint being exploited, that has to be fixed within 24 hours. If the severity is high, the fix has to be done within 7 days. For instance, the system suffers from reflected cluster scripting in search endpoints, or you have hard-coded secrets in the application source code that is exploited. But if the score is medium, the fix can be done within 30 days. For instance, you have debug mode enabled production environment, because the impact is less, or missing security headers or developable error messages within 30 days. But if the score is low, the fix can be delayed within 90, can be delayed and then taken care of within 90 days. For instance, you have adopted dependency versions. Remember, I talked about Python's depending so much on the versions of the dependencies, or they have manual configuration issues. So that can also be done within 90 days. So the findings. So by the time you are done with going through the scripts, implementing the commands there, you would have identified about 9 vulnerabilities. Critical will be 2, high will be 2, medium 3, and then low will be 2. That's the inventory. And then the exploitation rate, but when you are through with the codes, you would have attempted 15 exploits, and 12 of such, which is 80%, would have succeeded. So for SQL injection, you have 100% success, where you are going to launch 3 attempts, and the 3 attempts should be successful. Command injection 100%, cluster scripting 4 or 5, that's 80%. Information disclosure 100%, that's 2 attempts will be successful out of the 2. And then for failed exploitations, privilege collection should fail, container escape should fail, database takeover will be partially successful by the time you're done with what we provided. Then the overall risk rating will be high. So this will be the risk distribution. Critical risk will be 22%, high risk will be 22%, medium 34%, and low risk will be 22%. The risk factors or key risk factors. If you're able to bypass authentication, that's going to be critical. If you're able to perform remote code execution, that will be critical. If sensitive data is being stolen, then that will be high. If system integrity is compromised, it will be high. And then if system availability is tampered with, then that will be medium. So yeah, we have the immediate remediation priorities. I've talked about the fact the fixes have to be done from 24 hours up to 90 days. So this is further explaining what can be done in the source code, where you have to replace the variable lines with the coded lines. But this is what this is showing. So we have from phase 1, phase 2. Phase 1 deals with the immediate actions, which have to be performed within 24 hours. Then phase 2 deals with within 7 days, phase 3 within 30 days, phase 4 within 90 days. And then these are the detection recommendations. What should we recommend according to PSI, DSS requirements, and also the world's top 10 policies that have to be implemented. So let's go back to the script and see what we can implement within the time. So this is the script for Lab4. So the first thing we need to do, as we've been doing, is to check whether the containers are all running. Remember there are 6 containers, and all of the containers must be running. And to do that, you have to run this docker space ps command on Kali. So I'll go to Kali, I'll log into my Kali. Let me grab a terminal. Paste selection. Sorry, paste clipboard. nothing was done. Maybe the copying wasn't done. Let's try this again. Right click, paste clipboard. All right, it shows nothing in the container. So let's go back to the script. So since no container is running, let's make sure we get all of them. We start all of the containers by running this Docker compose up. Paste clipboard. Oh, it says configuration file provided not found. So we need to change directly to the projects folder. That to be CD. Yes, it is. Okay, so we're here now. Now let's run it. Was it collapse of terminal? Paste clipboard. What happened? Let's do that again. That's paste clipboard. All right, so it's starting now. It's starting the machines or the VMs, the machines. Okay, let's see if everything's fine now. Okay, it shows content Elasticsearch running, Secure Bank, MySQL app, Kibana, Lost app. Okay, they are all running. That's all right. Back to the script. So the first thing is to run Lab4, which is vulnerability assessment and penetration testing. So in one, what you need to do is to do automated vulnerability scanning by doing port and service enumeration with Nmap. That's step one. So simply by running this command, you just run this command, copy this and go to terminal. I collapse, I closed that by error. So let's change that actually. Press clipboard. Okay, so this is one, okay, it's done already. Failed to resolve secure bank, okay. So it means we need to get the IP address of this application. So let's see if we have the command in the document. So it said, if you fail to resolve secure bank, then run this. So we're going to run this, copy this to terminal. Press clipboard. So this is the IP address now. So we are going to run this again. We replace this with IP 172.18.0.4. So it's scanning for us now. The scanning is done. So we have port 80 is closed, and the service HTTP. Port 443 closed HTTPS. Port 5000 is open HTTP, and it is our application pattern 3.9. So this is what they're looking for, port 5000, and it's open so we can exploit. So So what we did was to run this, it reviews an IP for us, and then we replace the IP. Here we have from IP above, just replace the IP you got. That's what we did. So if you want the payload to also review that is the Nmap scan to also review the operating system, then we need to include the dash O flag or switch. So we can just copy this. Copy this and then to terminal, paste clipboard. Then the IP 172.18.0.4. Let's confirm that. Let's see the IP 18.0.4. So, yeah, that's correct. So it's scanning now for us. Let's see. Okay, so it's done now. This time around, the scan is going to reveal something more for us. All right, so the scan result shows it shows that the operating system for the system we are scanning is Linux version 4.15, and then it's connected to Macrotic Router OS version 7.2, and that's what we want to see. And then that's given us the hop, one hop, that's the network distance. So let's go back to our terminal. Sorry, the script. So yes, we are. So we can actually run this this other command. What this is going to do for us is going to store the scan result in a directory called evidence. It will create a file called nmap_scan.txt. But remember to replace the IP address. So let's do this because we need this in your report, in your module 6, we have executive report. You're going to have to provide the screenshots of this nmap_scan.txt script. So let's run this and then store the results in that directory for us. Paste clipboard. And then I'll come to where I have IP here. 172.18.0.4. After scanning, the result will be stored in the directory called evidence, and then the name of the file will be, yes, it's done, will be nmap_scan.txt. It has created that for us. We will view that later. As a matter of fact, if you check this folder, if you move into this folder, which you did in lab 2, you see that directory called evidence. If you do ls, you see that file being one of the files listed there. So step 2 is to perform web variability scan with Nikto this time around. And then what you need to do is to just copy this command to your terminal. It's going to use Nikto to scan the web application. And then it's going to create a file called nikto_scan.txt and store it in evidence directory, in addition to nmap scan I will do. All right, and then I've added a note here. You may have to cd to this evidence directory before running the above command. You may also have to replace the secure app with the IP address, okay? The IP above, from above that we source. You may have to replace secure app, just replace this with the IP address, and that will be fine. And then step 3 is where you're expected to perform automated SQL injection with SQL map. So to do that is for you to, one is you can perform basic scan against the login form. Just run, you can run this three lines of command at the same time, or you run one by one. When you run the first one, it's going to ask you to run the second one. You just copy this and run, and then the third one. And then we have for you to perform full extraction. We want to extract databases, tables, columns, and data. So these are the commands you need to, or the pillars you need to run. Then for manual SQL injection testing, there are several steps we provided here. You want to confirm if vulnerability exists, what you call tautology-based SQL injection, this is a command. Remember to replace this IP address with the valid IP address that we got, and then run the entire command. It's going to confirm if vulnerability exists, want to be able to exploit. For union-based SQL injection, you want to extract the version of database versus the payload to run. To extract database names versus the payload to run. To extract columns from user tables versus the payload, just dump them on the terminal. For it to dump more credentials, this is the payload. For it to perform error-based injection, this is the payload provided. For you to perform time-based blind injection, so this is the payload from time call. This is what you do. All right. As a matter of fact, it's even better you begin from call. Well, it'll be better for you. Yeah, just take from call and then dump it. For it to perform Boolean-based blind injection, these are all variants of SQL injection. For true condition, which will return the content, paste this command. For false injection, for condition, paste this command, this payload. For it to check if the account requires login or not. A particular account requires a particular web application wants users to log in or not. So this is a payload to do that, to test that. So now, when you run this payload, you're likely going to have an error. So if the message that comes up is 302, it means that the account endpoint actually requires that you log in authentication. And then step 2 is to log in first and then capture the session. Okay. To do that, just copy this payload and remember to replace this IP address with the correct IP address of your machine, your application you are testing. To check what cookie was saved, there's a command to check. The cat command reveals that. To use session cookie to access account versus the payload, this access account with valid cookie. For you to access or to try command injection with the session cookie for the basic UMI, run this command. Remember to replace this IP address with the value one you got for the application. For you to use the list command versus the command, remember also replace the IP address. The port number remains. And then to use your URL encoded semicolon versus the payload. And then to check what endpoints actually exist in your application. This command is going to be reviewed. Now remember, when you have secure bank app, remember to replace it with the valid IP address that you would have gotten from the previous steps. In step 6 is where you perform subshell redirection. So this commands 1, 2, 3 command do that for you. Remember where you have secure backup to put the valid IP address. That is very important. This is part of this. So just join this now. For you to perform process scripting exploitation, that is number 4. About 2 steps are provided here. For reflected class subscription confirmation, this is going to be executed, and then to, of course, see where you have good IP. Replace this with the IP address of your application. For you to perform URL encoded, run this command, then replace this with the valid up to this point with the valid IP address. For it to see to listener to cache stolen cookies, so you can start listener on Kali tools command by running this ncat command, or you can do that using Python simply by running this. And then we have a drum-based scripting. To perform that, run this command, and then make sure you replace, you edit the command or the payload, and then put the valid IP. To perform post exploitation, for instance, you want to do data extraction via SQL injection. So you want to extract all users manually. So this is the command to extract all users manually and then replace the IP address. For it to find sensitive files via command injection, versus a payload that does that for you. Replace the IP address and then run this for you. For you to find out how many columns a table has, of course, a relational database is made of tables and columns. For you to know how many columns are there in a particular database, so that's the command to do that. From 4 to done, it's going to reveal that for you. To test each position with visible marker, for it to perform or to check for privilege escalation to see if you can actually escalate privilege. If it's allowed, if it's possible, if the application allows to escalate, you can check for pseudo privileges here, and then check for the SUID binaries, which I showed in the presentation slide, and then you can check for writable files here, the first 20 writable files. You can check for cron jobs using the cat and the list command. You can attempt container escape, which I talked about by running this command one by one. Then you want to perform lateral movements from inside your Kali environment. Now you want to move up, down, left, or center. So first you want to attempt to access MySQL from application container. If that is possible, you have to run this command. Remember to replace secure bank with your valid IP address. If you want to attempt to access Elasticsearch as a root user, even though you're not a root user, that's a payload. Run this on terminal. Kibana can be accessed through this to see if that happens. You want to perform password spraying, this is the command. Make sure this IP address is the IP address of your Kali environment. Here, the attacking machine. You want to, in step 4, where you want to create persistence mechanisms. First, you want to create backdoors in users MySQL. So that's the command from this up to this. You want to create reverse persistence. That's the payload that does that for you. Replace this IP address with the IP address of your application or your web application. You want to create scheduled tasks for persistence. That's the payload. You want to modify the application backdoor so you can always gain access. You want to make it easy for you to explore the application anytime. So that's a payload. So that's what you need to do. Now you need to complete all of these steps to finish up what you have in Lab 4. All of these commands have been tested and they're working fine. You simply move. Everything you have to do here are done within the terminal environment. So you just copy them to your terminal and see the results they provide. I hope this helps so much in understanding how to perform vulnerability assessment and penetration testing, which is the focus of this lab. See you in the next lab. Thank you.